back live. Well, some of us are live anyway, some of us are not. In the studios of WLCN. We have with us Chris Miller. You know, Judith Kay, I was thinking about the degree of sophistication of that weather station out there. It's kind of a quiet operation, and it's intended to be that way. You can't get on the place without a pass, and that's all right, too, because they need to do their job. They don't need to be bothered with a lot of people. But I'm thinking about the degree of sophistication of weather predicting and how terribly important it is to each and every one of us on, in our respective jobs or our recreation or just sitting on the back porch. You know, I'm thinking way back, remember the D-Day decision as to whether to go or not to go. And there was this terrible problem about the weather and the channel. And let me tell you from experience, the English channel can be something else. And there was Eisenhower trying to make a decision, and think of the burden that put upon his weather prognosticators. It's an interesting human issue story, and how that impacted literally thousands upon thousands of people.
Oh, absolutely. For one thing, I wouldn't want to be the guy that have to make that call. I mean, you're talking about thousands of people's lives and changing world history. Is with that one prediction.
Exactly.
But I'll tell you, a lot of what in the early days of meteorology and weather forecasting, we didn't have the computer power that we have now to make the predictions that we do. And back then, a lot of it was, some observations and looking at what's going on. And the weather doesn't
really
always...
crude when you stop to think about it in comparison to today. And yet, it's remarkable how accurate they were given the tools of the trade at the time.
Oh, absolutely, absolutely. There's no question about it. And we learned a lot about weather forecasting from military meteorologists, military weather forecasters back in the day. In fact, a lot of the technologies we use, they owe their existence to military operations. Radar, for example. Radar was not used for weather forecasting really until we got to the early 50s. Back during World War II, radar, well, we wanted to see the enemy planes coming in. And especially the British were really the first ones to jump on the technology of radar because they were looking for their, as the bombers were coming in every night, they were looking for the planes. Well, some cases, there was this other stuff on there, and he said, well, it's not planes. This stuff's getting in the way of being able to look at planes. And the meteorologist said, oh, wait a minute, that's probably rain or clouds or something out there. And so when the war ended, well, the military had all these surplus radars then. You didn't need all these radars around. So universities said, well, give those to us. We'll experiment with those. And it was from the late 40s into the early 50s when a lot of experimentation was done on radar, and they determined, hey, we can see a lot of stuff with this, and it just exploded from there.
Was that like the first technology for weather forecasting?
The first...
Other than licking your finger and holding it in the air.
The first big technology, I mean, you can take it all the way back to the simplification of that, what we were talking about, temperature, air pressure, the basics of weather. That goes all the way back to the Revolutionary War, when people like Thomas Jefferson and Ben Franklin and others were taking daily weather observations and saying, hey, look, as this changes, this happens. And they were trying to make correlations between these things. They were really kind of the, Ben Franklin was probably really the father of meteorology in the United States. There's no question about it. He was a very intelligent guy when it came to stuff like that. And he experimented a lot. We've all heard about with the lightning, with the key on the kites and all that. And, very dangerous thing to do now, as we know. But experimenting years ago was you took your life in your hands. But it was the same thing with weather satellites. We take that for granted. You see it on the evening news and you're looking, okay, here's the clouds moving in, and the TV weather people show you that. We look at those to pick up on trends as far as, forecasting in the short term over the next day or two. But weather satellites, they got their start during the Cold War. From the late 50s through the 60s, because, when the Russians were the first ones to throw a satellite up there, I said, well, we need to do that too. And so we did that. And we said, hey, look at the clouds, look at the clouds. And we watch how these things move. So, you know, a lot of it owes its existence to military operations, and some of these things kind of by accident that we picked up on.
And by the way, it created some new jobs in the TV industry.
Somebody would like to ask.
Do you have a phone call? Oh, okay, all right. Let's get the headsets on here. We do have a caller. And go right ahead, caller. If you can hear me, I'll hear you.
Yeah, well, I can hear you fine, Bill. Even a little gruff, you're still with us, that's for sure. You and your lovely co-host do a great job. But you were mentioning things like radar and everything, and relating to weather. In the wintertime, driving in open areas, especially like rural areas, I notice a lot of times you'll see small formations of air, and they might act like a miniature tornado even. Might only be a couple of feet tall, so to speak, with swirling motions like tornadoes, and they can move. You can see it when they do it with snow, snow particles or wind and dust in the summertime, especially in your rural areas. Pertaining to radar, what does it take to pick up something? How much of an impact does it have to be before it can be spotted on radar?
Okay,
like
Chris.
a tornado or something.
Okay, yeah, that's a really good question. When it comes to radar picking up circulations, Doppler radar is really what we need to do that, because we got to see the motions in there. Now, these small circulations that the caller was describing on the side of the road, out in rural areas, things like that, they're too small for Doppler radar to see. But when you're talking about a tornado with a storm, the circulations with those, when they start high up in the storm, can be a mile to sometimes 3-4 miles across, and that's what we see on radar, is those circulations higher up. And we rely on the storm spotters, the volunteers that we train every year from February through March, to see the smaller things near the ground to report to us.
Yeah, very interesting, that's for sure, because you would think you'd rely on a lot more of like people and spotters on that stuff. Can they develop the small ones that I started to allude to? Can they develop into bigger, even though they're smaller and more close to the ground, so to speak?
The real small ones, they can develop more if they have something to develop on, or with, I should say. On a clear day, if you see a little spinning on the side, there's really nothing for that to develop further. But we have seen cases where the smaller ones can hook onto bigger rotations up in the clouds and develop into full-fledged tornadoes.
That'd be scary, but interesting show you have, sir, and appreciate your participation, and you guys get on with it. But good to talk to you and listen to you. Thank you.
Yeah, thank you very much. Appreciate the neighbor. Bye-bye. Thank you.
Yeah, thanks for the call.
648-5510. If anyone else has a question they'd like to ask Chris Miller, he's a very good answerer.
Yes, an excellent answerer, I can tell you. Let's talk about, as I started to say, it created a whole new genre of employment when you have on TV our weather predictors, prognosticators, reporters, however you want to define them. And they talk about fronts, cold front, warm front. Let's just basically describe a cold front. We think we might know what that is, but for the purpose of everybody out there, put it in definitive terms, if you will, sir.
Sure. And what I'll do is I'll go back to our discussion of when we were talking about air temperature. When we're moving air temperature, if our winds come from the south, we get the warmer air from the southern states, from the Gulf of Mexico, those areas. But there are air circulations up in Canada or Alaska that will bring the colder air down toward us. And when those two air masses collide, when those two air masses are coming together and you got warm air pushing up against cold air, that is what we call a front. That front is a different air mass, or that the air moving in right at the front has different properties. It's either colder with a cold front and drier, or with a warm front, it's warmer and has more moisture. So that's what we talk about. And when you got air masses different temperature, different humidity levels colliding with each other. That's what causes some of the violent storms. That's what causes the air to lift up really rapidly. The faster it lifts up, the stronger the storms are, or the heavier the rain is that we get.
When you send your balloons aloft in the morning and the evening with the little attached machine, what, other than the winds aloft, what are you looking for in the winds aloft?
Well, we're looking for other things too, such as on that little box. We call that a radiosonde, and that little piece of equipment that we tie to our large balloon has a temperature sensor on it. It has a humidity sensor, so we're measuring the temperature, we're measuring the humidity of the air, and we're also measuring the air pressure. Now, we know as we go up, the air pressure gets lower. Air pressure is just its weight. You know, when we stand on a scale and we weigh ourselves, and it tells us...
Well, let's not talk about that.
I don't want to talk about that either. But air around our planet, the atmosphere, has weight. And when it pushes down, that's air pressure. And so with high pressure, the higher the pressure is heavier air, the cold air is heavier and sinks, and the warm air is lighter and rises. And so there's different weight of our atmosphere as it moves around. And so we are trying to see what is the air pressure at 5,000 feet, 10,000, 20,000 feet above the ground, because that tells us how the weather, how the air masses are changing. It tells us where the jet stream is. The jet stream is that high-level wind that moves along.
I saw him draw it on TV.
Yeah.
Talk about it.
That's it's a band of wind. It's actually an area of wind. It's like a tube, actually, a tube of wind that moves along. Oh, and it changes, but it's around 30 or 40,000 feet. And we call it the jet stream because the jets like to fly up at that level, and they use less fuel if the wind is blowing a tailwind coming from the west, if they're going west to east. Now, if they're going into it, they'll drop to a lower elevation because they don't have to fight that higher wind. They don't use as much fuel that way. So we call it the jet stream mainly for the aviation reasons.
I didn't know that.
Yeah, and our little box, that little radiosonde measures all that from the ground here at Lincoln all the way to a height of about 90,000 feet above the ground. And then the balloon pops, and that little instrument falls back down to the ground.
Why don't you repeat that altitude, 90,000 feet?
90,000 feet.
That's remarkable.
Yeah, that's almost, you think about it, that's about 18 miles up.
I was going to say, it's about 18, 19 miles.
Yeah, it's a ways up there. And but all the while it's going up, it's sending the information to us. We don't have to get it back to get the data from it. Every second, it sends it back to one of our computers, and we can look at that then.
However, you would like to get it back if it lands in your field, Mr. Farmer. They would like very much to have it back.
We talked about that before when we had you, Chris.
Sure.
The frequency upon which those devices are returned. Visit that again just a minute. You send up 2 balloons a day?
We send up 2 balloons a day at 6 a.m. and 6 p.m.
Who has to get up for the 6 a.m. one? You could have Jim do that. He's up anyway.
We have staff members that are out at our office 24 hours a day, often 2 people, sometimes 3, especially during hours like this. But we have a section of our staff that comes in at 4 o'clock in the morning, and they prepare that weather balloon and radiosonde instrument, and they have other duties as well. Quality controlling data and that type of thing. But 6 o'clock sharp, they send it up, and it gets sent up around that time, very close to that time, all over the world at the same time. There are 70 places across the United States, and we get about 20% of those back.
20%.
20%. Yeah, it's not a huge number. They're kind of small. It's about the size of a shoebox. You know, if you bought shoes for a very small child,
yes,
that's about the size of a very small child's shoebox.
Well, if it did land in the woods or something, you might not find it. But I bet a lot of the people who are out in the fields would send it to you.
And that's where we get the vast majority of them, unless it lands in the middle of a field. Let's say it lands in the middle of a cornfield. It might not be seen. It's kind of small, so it may not be seen laying out there. But we do get most of them back from rural areas. Speaking of trees, we did get one back from somebody that saw one hanging in a tree, and we put a date on each one of these. We write on there where it was sent from, the date. It's a harmless weather instrument. people don't like seeing things with wires sticking out of them.
Oh, right.
In trees or laying in their yards. Bomb squads have been called out many times for
I
these.
bet that's true.
But it says on there this is a harmless weather instrument. But there was a woman that found one up in a tree and had been there almost 4 years.
No.
Yeah.
How'd she get it out? Climb?
I don't know. I didn't hear that part, so I'm not sure if it fell out or the tree fell or what. But it had been up in this tree for 4 years.
There are varying degrees and types of weather stations, but the one that we have here today is particularly sophisticated out here on Route 10. And how many of those do we have, and how far apart are they, approximately, how far apart are they located?
Sure. Across the United States, there's 122 offices like ours.
How many?
122.
Really?
Yeah.
I would have thought there had been more.
We did at one time. Back when I started in the Weather Service 25 years ago, we had over 300 across the country.
Huh.
But like many agencies, we had cutbacks and budget. We're federal agency, so we have felt the sting of budget cuts. But we have 122 of our offices, and one of the reasons we were able to cut down to that number from years ago was because of our Doppler radars and some of our technologies that can go out a little bit farther. And the offices are spaced roughly, we try to keep them about 125 to 150 miles apart or so. Some areas out in the western U.S., they're a little farther spaced apart, and mainly that's because there's not a lot of communities out in Montana and areas like that. They're pretty spaced apart. So, but at least here in the Midwest and the eastern U.S., a lot of it has to do too with where's the population. That's one of the main reasons we're in Lincoln, is because the largest cities in central Illinois are all within less than an hour or so drive of Lincoln, and that's the optimal distance for the Doppler radar. So when you're looking at Peoria, Springfield, Decatur, Bloomington, Normal, Champaign, Urbana, places like that. So
It works.
Chris,
it works, yeah.
Supposing there's some young high school student, a young boy, young girl, who thinks, I'd like to be a weather person, and they're really serious about it. What courses and what course of action do they take as they progress? And of course, you just can't say they're going to have a year or two training to do this.
Oh no.
So let's say Judy's grandson or granddaughter decide I want to be a weather person. Tell them how to go about that.
And I'll tell you something. Usually it starts at a pretty young age. I was 8 years old when I decided this is what I wanted to do.
Is that right?
Yeah. And many of my coworkers, it was somewhere between, very young or into high school. Very few people go to college and say, I don't know what I want to be. I think I'll be a meteorologist.
Yeah.
Because there is a lot of preparations ahead of time. What I tell young people, and I talk to young people about this all the time, is from grade school all the way through high school, if you have an interest in math and an interest in science, that might be a field
That's
for
your
you.
background.
Or engineering. We take a lot of the same courses. But for meteorologists, math and science. In high school, taking physics and chemistry and some of these more advanced sciences. Then when you get to college, there are about 100 universities nationwide that offer degree programs in meteorology. And we have several here in Illinois, not too far away. U of I in Champaign-Urbana has a good program. Northern Illinois, Western Illinois, they all have programs. And there, you start out your college days, again, taking math, taking science, and then getting into the meteorology classes.
Well, we appreciate very much your time, Chris Miller. We always enjoy talking with you because you always bring a new slant in the thing. Judith, Kay, and Jim, I'd like to insert a commercial for Lincoln College, if I may, before we sign off. On Wednesday, May the 9th, we're going to have a big jazz concert out there. The St. Louis Rivermen are going to be in town, and it's a fundraiser for the Fine Arts Department of Lincoln College. And we'd like to urge, there's going to be limited seating because it's going to be in Johnson Center. It only holds 300 people. Tickets are available at the office of the president at Lincoln College. And I have a few in my pocket too, but don't forget, get those tickets bought so we won't miss out on that. Wednesday, July the 9th, July.
You're jumping ahead.
Must have a high temperature today. May the 9th, and want to be sure and remind you to take advantage of that. Chris, we always try to sign off with a comment pertinent to the subject of the day. And I found one here that would apply to you in particular, I would guess. Another place where no one is ruined by success is the Weather Bureau. Thank you very much for Viewpoint.
Oh, dear.